In this video, we will analyze the key attributes of a quadratic equation from standard form. First, let's remind ourselves what standard form looks like. So standard form of a quadratic equation looks like y equals ax squared plus bx plus c. A, b, and c are all constants and coefficients of our variables. So a is always the coefficient of our x squared term, b is always the coefficient of our x term, and c is our constant. It's going to be helpful for you to identify what a, b, and c are going forward. When we graph a quadratic equation, what it's going to look like is a U-shaped curve called a parabola. So what I want you guys to do is I want you to pause really quick, and I want you guys to open up Desmos, and I want you guys to graph these two parabolas. So what does that look like for y equals x squared plus 2x minus 5? Well, we're going to do a rough sketch of that here. So we know we had the vertex of that parabola. Notice I'm using that term here. The bottom point here, and then it looked like a U shape in either direction on either side. Notice that I kind of got the positioning as close as I could, but I'm not really worried about where it's exactly crossing. This is just a sketch. What do you notice about y equals negative x squared plus 3x plus 7? Well, notice that this one actually faces downward. When the a value, so what is the a value here? The a value is positive 1. If the a value is positive, then the parabola opens up like a smile. Okay, so just like the smiley face here, that parabola opens up. But notice the a value is a negative 1 here, and that parabola opens down like a frown. So if that leading coefficient, when it's in standard form, is positive or negative, that affects the way our parabola opens. Next, we're going to talk about the really important key attributes of a quadratic equation. A couple of those are the axis of symmetry. So an axis is a fancy word for line, and symmetry means that it's going to look the same on either side of that line. So it is a line of symmetry for the parabola. This line has to pass through the vertex. Okay, so notice on this picture down here, I have this purple parabola drawn. This green line going vertically through it is my axis of symmetry. So this vertical line. So even if our parabola faced down, that axis of symmetry would still be a vertical line. Remember Hoy and Vux. Our vertical lines have an undefined slope and an x equals equation. And we actually have a formula for the axis of symmetry. Our equation needs to look like x equals a number. How we get that number is using the coefficients from the equation. We have negative b over 2 times a. So here for this equation, y equals x squared plus 2x minus 5. Notice that this is in standard form. Our a value is 1, our b value is 2, and our c value is a negative 5. So I'm going to find the axis of symmetry. Well, the axis of symmetry is going to follow that formula. X is equal to negative, our b value is 2, over 2 times our a value, which is 1. So I have negative 2 over 2, which is negative 1. So the equation for the axis of symmetry of this parabola is x equals negative 1. Notice that this is the line that's graphed here. At negative 1, we have 0 and negative 2 here, so halfway between that's 1. At x equals negative 1, we have that vertical line. Notice that that vertical line passes through the vertex. Also notice that because the axis of symmetry passes through that vertex, it actually has the same x value as the x value of the vertex. So knowing the axis of symmetry can actually help us find the vertex. That's going to give us that x value. Now, what is the vertex? The vertex really is the point that connects the two sides of the parabola. So we have that left side coming down and that right side coming down, and they join together at that point. It's also called the turning point of the parabola, because as I start to move from left to right, that parabola starts to change direction after that vertex is hit. So how do I find the y value of the vertex when given that equation? Well, if I'm given an x value, I can find the y value. I can plug in that -1 and find the y value. So I'm going to evaluate the equation when x equals -1. -1 squared is +1. -1 times 2 is -2 minus 5. And we get a y value of -6. You can verify this using Desmos. So you have a way to check your work as you're going through some of these examples. Let's do some. So I'm going to give you the equation, and you're expected to find the axis of symmetry, the vertex, and then kind of sketch what that parabola would look like. Whether it's going to open up or down, and then you're going to label the vertex and axis of symmetry. Well, how do we find that axis of symmetry? Remember that formula is -b over 2a. Our b value is always the coefficient of that x term. So here it's 8. And as I work through that, I get an x value of -4. That means that my axis of symmetry is the equation x equals -4. It's not okay just to write -4. You need to state x equals. Because what if it was y equals? Well, that would be a horizontal line, and that's not what we want. Our axis of symmetry is always vertical. Then how do we find the vertex? Well, if I know the axis of symmetry, I know the x value of the vertex. So use that value to find y. I now know y is -1. So my vertex has an x value of -4 and a y value of -1. Now, to sketch this parabola, is this parabola going to open up or down? Remember, we know that when our a value is positive or negative. Our a is a +1 here, so we know our parabola is going to open up. Our axis of symmetry is x equals -4, and our vertex is -4, -1. All right, the next parabola's equation is y equals -x squared plus 10x minus 23. The axis of symmetry is x equals -b over 2a. Notice that the a is that -1 here. So when I simplify out, I get a -10 over -2, which becomes a negative of a -5, which gives us +5. So I know the axis of symmetry is x equals 5, which gives me the x value of the vertex. So I use that 5 and plug it in. Notice here that the negative is outside the parentheses. I'm using that negative and after I square that 5. So it's the negative of 5 squared plus 10 times 5 minus 23. And we get y equals 2. So my vertex then is +5, 2. Now, is this parabola going to open up or down? Because my a value is a -1, it's going to open downward. With my vertex being that 5, 2, and my axis of symmetry being x equals 5. All right, the next problem. The axis of symmetry is x equals -b. Notice b is actually a -12 here. So negative of a -12 over 2 times a, which is 3. So negative of a negative becomes a +12 over 6, which equals 2. So my axis of symmetry is x equals 2. Now use the 2 to find the y value of the vertex. So 2 gets plugged in everywhere I see an x. So 3 times 2 squared Notice I didn't get rid of the 3, and that was the coefficient and it needed to come down. Alright, so 3x squared minus 12x plus 5. So that our y value is negative 7. Is this parabola going to open up or down? Our a value is positive, which means the parabola opens upward, with our vertex being 2, negative 7, and our axis of symmetry being the vertical line x equals 2. Alright, our next parabola is y equals negative 3x squared minus 24x minus 42. Try to pause with these problems and get the answers before I do. So here we're going to have negative b over 2a. Negative, our b value is a negative 24, so that goes on top, over 2 times our a value, which is also negative. So we have a negative 24 over 2 times negative 3, which becomes negative 4. We have the negative of a negative, which becomes a positive, and a positive over a negative is a negative. That becomes our axis of symmetry, x equals negative 4. Plug in the negative 4. Watch these negatives. They can really mess up a problem if we're not careful. Here, I'm squaring a negative 4. Negative 4 times itself is a positive 16. And then we have negative times a negative here, which becomes a positive 96. And then I get y equals 6. Because a is negative, this parabola is opening down, with our vertex and axis of symmetry being x equals negative 4. Notice here that our c value is actually 0. But we have an a value of negative 1 and a b value of 4. So x equals negative b over 2a, which becomes negative 4 over negative 2, which is a positive 2. Use that x equals 2 because the axis of symmetry has to pass through that vertex. Notice that the negative here is outside the parentheses. It's not part of the 2. So we get positive 4. So 2, 4, does our parabola open up or down? It opens down because a is negative, with our vertex of 2, 4, and our axis of symmetry. Alright, our last problem. A lot of students might say that our b value here would be 8. But it's not. Notice our b value should have an x with it. But notice we don't have an x term in this equation, which means our b value is actually 0. This 8 is our c value, our constant. So we're actually going to use 0 for b. Well, 0 over anything is just going to be 0. That means that x equals 0 is our axis of symmetry. So to find the vertex, plug in 0 for x. And I get y equals 8. So, does this parabola open up or down? It opens downward, with our vertex of 0, 8, and our axis of symmetry at x equals 0.